So I'm working here with this commutator. This one's made by DragonFly R&D Incorporated out of Ridgely, West Virginia. And I'm just evaluating it to see if it works. I had to improvise a power cord to it. It's a 9 volt with the center pin positive. And I'm going to power it up. There's two connections to this for the motor. There's one to this is the control module here, the box. It's potted. I'll show you what's inside there in a little bit. But there's two connections. There's this connection here to there, and then there's one from the motor. And the connections are actually polarized by pin count. So you can see you can't plug it in wrong. There's only one way to plug it in. These are pretty nice connectors, made by Dale, I think. And so if I don't have a manual on it, I've just been looking at it to see if it works. And we'll check it out now. I'm going to go ahead and power it up. There's a LED power indicator. I'm going to connect 9 volts to it. It is, it did come alive there. So you can see I've got a mirror here so you can see actually underneath as well as on top. So most of the action is actually underneath. So you can see this pole here is where you would actually suspend the cable to the animal. And it's got two electromagnetic sensors, I guess reed switches. When you get near one, it rotates in that direction. Where you go towards the other one, goes in that direction. And it's all geared towards, keeping the cable from getting wound up. And then there's this potentiometer here that just controls the amount of response. So I can turn it, this is all the way down. And you can see it's taking larger steps now as you increase, as you turn this dial clockwise, the steps get larger, or the corrections get larger. It's a little noisy. I guess it's because it's a stepper motor. But it seems to work. This is where you'd clip on the cable, and as the road moved around, this would tend to follow it. And the electronic connections would actually be here on these pins here, and they would come out here on the top, and that would go into your amplifier. So it appears that the mechanical part, or the electromechanical part of this commutator is working, and it's pulling about 300 milliamps on the steps. At the maximum. Well, I'll go all the way to the max here. Let's see. It's about 300 milliamps. And it appears to work very well. So I'm going to show you what's inside the box here now. I'm going to just connect the power. And also on this connector here, you'll notice there's a dot right here, a black dot. And there's also a black dot here. This indicates that this plug should be plugged to that, evidently. Because on the other end of the plug, there's no black dot. So I guess it's polarity sensitive, so I'll have to make a note of that. But anyway, here's the control module. Take a look and I'll show you what's inside. It's got 4 Phillips screws. These are nice little project boxes. I've used them a lot. It's interesting to see there's this equipment made using them. These are nice sturdy boxes. And so looking inside, it's pretty unusual. It's potted, so you can't really do much with it, I don't think. If you try to go into it to work on it, you would probably be destroying it. So it's basically hand fabricated, hand built. So I'm going to leave that alone. I'm not going to disturb this because it's working. And there's no need to bother it. I think I will add some sort of color paint on this to make sure that the connector is plugged in correctly, because it would be easy to overlook that. I'm going to put a dot of paint here and there for that. Now I'll show you this piece here. This is the actual commutator. I had it clamped so it could be suspended in the air. So I guess the next step is to evaluate what is going on here. So I am going to mark this connector here with some green paint. I see there's a blue smudge on the side here of paint, but there's nothing corresponding to it. There, I've got the green dots indicating it. I want that to be a round dot, so I'm going to have to hold it level while it dries.